So in this video, we're going to have a really brief look at how to use your graphics display calculator to confirm results that you've got manually. Useful in tests, I suppose, or in assignments where you might not have the answers to look at yourself. Plus, it's just a handy skill to know how to find the derivative using your calculator, because you might be given a function that you don't know how to differentiate. This will at least give you the opportunity to do that. So I'm using an example from the chain rule lesson, and you can see that we've got f of x equals this expression here, and we worked out the derivative would be this expression here. So on our calculator, we are going to, first of all, define the function. So f1 of x, that's control the button next to 9 for that colon equals. And I've got x cubed minus x squared plus x plus 1, and the whole thing is raised to the power of 5. Done. And now I'm going to work out the derivative. It's really straightforward. Menu, 4, and derivative. And then it's always with respect to whatever the variable is that you've got here. So almost always it's x, but it could be dt, if that's the way it was defined. And then you're going to go f1 of x, like so. And there's our answer. 5 times 3x squared minus 2x plus 1 times x cubed minus x squared plus x plus 1 to the power of 4. And that is what our answer was. So that's all good. Just a couple of little asides then. I could, if I wanted to, I'll use the long way so you can see it, control that button. f2 of x is equal to, or is defined as, the derivative d by dx of f1 of x. Note the way it's notating that. D by dx of f1 of x. And now f2 of x is the gradient function of f1 of x. So if I call upon f2 of x, I get that same expression. And if I need to evaluate it, so if it was like find the gradient at x equals 2, I can go f2 of 2, like so, and it will give me the answer. Now, for a one shot, if you need to work out what the gradient is at 2, you can do this. Menu, calculus, derivative at a point. And you've got the variable is x, the value is 2. In this case, it's the first derivative. Click on OK. We'll do other derivatives later. And then we can put in f2 of x here. And it will give me, oops, I just did the derivative of f2 of x. I should have done the derivative of f1 of x. I just did the gradient of the gradient. And there's the same number there, 108045, 108045. And one last thing I'll say, and then I promise I'll be quiet. I can straight up go derivative, calculus, derivative, like so. So menu calculus. With respect to, let's just say make it t just for this case. If you haven't defined the function, f1, f2, whatever else, it's okay. You can put the function immediately into this. So I can go, say, t cubed plus 2t minus 1. And it will give me the derivative straight up here, 3t squared plus 2. So there's a few ways you can confirm your answers by looking at a derivative. Hope that was handy for you. That'll do for today.